let's have a look at an example here. All right, so I've specified R2 to be 30K and R1 is 2K, and I've got a reference voltage sitting here of 3.75. All right, we've got power supplies to the op amp of plus 15 and minus 15. We're going to assume at a starting point that this output is sitting, and I'll draw it over here, at a minus 15 volts, okay? We're going to call this voltage, as before, V1. All right, now we can write an expression for V1. Remember, that was done by a superposition approach, so let me just go ahead and write that again. So V1 is really equal to, this is R2 over R1 plus R2 times V in, and then that's a plus R1 over R1 plus R2 times the output voltage. Okay, now we're going to say switching occurs. So switching occurs when, of course, V1 is equal to that reference voltage, which in this case is 3.75. All right, so what we're saying here is we increase V in, V1 increases until it gets to a value of 3.75 plus a fraction more, and that's when this output will basically switch from a minus 15 here, and it will go up to a plus 15. Now we want to initially find this value of V in, which we're calling V in H. So this is when switching occurs. So I'm going to take this expression then for V1, I'm going to basically then equate it to 3.75, okay? So here we go. So 3.75 is going to be equal to this R2 over R1 plus R2. Let me put in values as we go. R2 is what? It is a 30K. R1 plus R2 is 30 plus 2K, so that's a 32K. That's multiplied by the special value of V in, which we're calling V in H. All right, then we've got what? R1, which is what? 2K. And this is divided by what? 32K, that's the R1 plus R2. And it is times what? The output voltage. The output voltage is a minus 15. So there is the 15, and I'm going to put the minus in like so. Okay? So that's really our switch condition. So what we've got to do here is try to find that V in H. All right, so what I'm going to do, first of all, is I'm going to multiply through by 32K. So I've got 3.75 multiplied by 32K is equal to what? Is equal to 30K times that V in H. Then I've got a minus here, haven't I? This is a minus 2K times 15. All right? We're trying to find this guy here. So really what I need to do is take that over to the other side. So I've really got a 3.75 multiplied by 32K. This going over to the other side becomes a plus, doesn't it? 2K times 15, and that is equal to what? It's equal to my 30K times V in H. All right, so what we've really got to do now is just divide both sides by really this 30K. All right, let's do this. So we've got 3.75 multiplied by 32K, and that's divided by what? 30K. And then we've got plus 2K divided by 30K times 15 is equal to V in H. All right. Now, if we were to work this out, this comes out to be 4, and this comes out to be 1, which is equal to V in H. And so V in H then is simply equal to what? It's equal to 5. All right. And so what we've really seen then, if I look at my graph of output versus the input here, I've seen basically my switch point V in H being equal to a value of 5. So the next step now is to really see when we switch back. At what point do we really switch back? So after we've switched, of course, this output voltage is what? It's a plus 15, isn't it? Okay, so this is our expression for V1, and we know switching again is going to occur when this V1 becomes equal to this 3.75. So what we're actually doing is we're reducing V in, which in turn is now reducing V1 until it becomes equal to 3.75. So we can say, as before, we can say switching occurs when basically this V1 is equal to the reference, which is 3.75. All right, so we're going to equate this expression now to 3.75. So we can say 3.75 is equal to, let's just put in values here, that's R2, which is what, 30K, divided by 32K, times V in, it's a special value of V in, it's V in L, it's the value of V in whereby we will switch back to a minus 15. And this is equal to a plus. This is R1, which is what? 2K divided by 32K times our output voltage. Well, it's now what? A plus 15. So there it is sitting at a 15. All right. So what we need to do now is find this V in L term. So what could we do here? We could simply multiply everything by 32K. So let's go ahead and do that. So that's 3.75 multiplied by 32K is equal to 30K times V in L plus 2K times 15. All right. So what do we need to do? We need to take this guy to the other side. And so we have 3.75 multiplied by 32K. This going to the other side becomes a minus, doesn't it? 2K times 15. And that is equal to what? 30K times V in L. So really what we need to do now is divide both sides by this 30K. All right, so we've got 3.75 multiplied by 32K divided by 30K minus 2K divided by 30K times 15 is equal to V in L. Okay. This term here, as we evaluated before, was simply equal to 4. This term is 1, so that's a minus 1, and that's equal to V in L. So V in L is really what? It's equal to 3 volts. And so really what we're seeing then, if I can plot this just over here, this is my V in, this is my V out. We saw that we came from a minus 15 here, so that's a minus 15. So that's a minus 15. We switched to plus 15 when this was a value of 5 volts. V in had reached 5. And then we switched back. This is, of course, my V in L term when V in had become 3 volts. And so really the hysteresis is what? 5 minus 3, which of course is 2 volts. What I want to do now is give you a design problem, and this is going to be in relation to the car turning on the fan to cool the radiator. So what I want to say is I'd like to basically turn the fan on when V in is equal to 5 volts, and I'd like to turn the fan off, so turn the fan off when V in is equal to 4 volts. Therefore, there's what? There's a hysteresis here of just 1 volt. Okay, I'm going to state that R1, to help you with this, is equal to 1K. And what I'd like you to do is really find the R2 value and also the reference voltage. Okay, so that's what I'd like you to have a think about. So take a break, have a go at this, and we'll work this problem together next time.